Alright guys, so today we're going to be going over point-slope form. Okay, we're going to be expressing the equation, graphing the equation, and also we're going to change it back into slope-intercept form. So how can we express an equation when given m equals 4 and the point 2, 6? So again, you got to remember that m is slope, so it's giving us the slope, which is 4, and a coordinate, or a point, 2, 6. Okay, so when we're given a point and a slope, we use point-slope form. And here's the equation for it. We get y minus y1 equals m times x minus x1. Okay, so here the y will stay just y, the x will stay just x. We'll be plugging in the x1, y1, and the m. Okay, and right up here, if you look, we have x1, y1, and we have the m. And so now we just substitute in what was given to us. We plug it in. And so our slope of 4, we plug in where m was at. Our x value, 2, gets plugged in right here for x1. Our y value was 6, gets plugged in right here for y1. And that's it, guys. It's that simple. So let's go ahead and look at another one. So how can we express an equation when given m equals 18 and the point -7, 1? So right here, what did it give us? It gave us the slope, which is 18, and it gave us a point, which is -7, 1. Okay, so the x1 is -7, the y1 is +1. Well, it gave us a point and a slope, so we're going to write it in point-slope form right here. So let's take those things and substitute them on in. Let's plug them in. All right, so the 1 for y1 goes in place of y1. The 18 for our slope goes in for m. And the -7 gets plugged in for x1. Now if you look here, last time we had minus, but because it's a -7, we get a minus -7, which becomes +7. And that's it again. Ta-da! That's it. All right. So it should be pretty easy to plug it in if it gives us the point and the slope, right? Now, how would we graph a function if it is in point-slope form? So first, we start with the original equation of y minus y1 equals m times x minus x1. Next, our x1 and our y1 are a coordinate we can graph, right? So we can take these two numbers here at the back of each side, and we can put them as a coordinate, and then we can plug that into a coordinate grid or a graph. Now, we're also given the slope, and we can use rise over run to plot the points based off of our original point, x1, y1. Okay, so let's look at an example of that. So right here, we have a function, y plus 2 equals 4 times x minus 3. All right, so again, the first thing we need to do is write our point, x1, y1. Right here is our y1 because it's with the y, and here is our x1 because it's with the x. Now remember, it's supposed to have a minus if it's a positive. So right here, our x1 is going to be a +3, and our y1 is going to be a -2, okay? Because it was a minus, that means this has to be a -2, which made this a plus. Okay, so we should have +3, -2, and we write it down. Now we take that, and we go and we plot it on the graph. So we look, 3, -2, 1, 2, 3 for the x value, and -2 for the y value, and there we go, we plot our point. Okay, now the next thing we want to do is we want to use our slope to plot multiple points. Remember, rise over run represents the slope. So what we're going to do here is we're going to rise up 1, 2, 3, 4 and go over once because that's what our slope is. It's 4. So that means it's +4 going up for every 1 unit we go over. And then we plot a point. Then we do it again. Up 4, over 1, plot a point. Now I can't go up any higher than this. I go off the graph, right? And so now what I do is I go back to my original coordinate, but I can still go down. But instead of going to the right and down, I'm going to go to the left and down. Because see how it kind of draws a line? We should be going down and to the left. So I go left 1, down 4, and plot a point. And again, I can't do that again, or else I run off the graph. So finally, we connect our points with a line. So we just draw a line connecting all these points. And there we go. Ta-da! Just like that, guys. Rise over run using the first point it gave us as a coordinate, and then using our slope. Okay, now, what about changing it into slope-intercept form? because again, that's how we're going to be able to graph it on our calculators, is in slope-intercept form. And also, personally, I just like slope-intercept form more. So we can start with an equation in point-slope form. Here's an example, y plus 5 equals 3 times x minus 6. Okay, next, we want to isolate y by itself on the left side. So we want y all by itself over here. So first, we're going to distribute the 3 into the parentheses to get 3x minus 18. So we took this 3, multiplied it times the x, and then we took the 3 and multiplied it times the minus 6, which gave us 3x minus 18. Now, you can move the 5 across by subtracting it on both sides. Because we had this 5 over here, we needed to move across. So what we did is we subtracted it, so it would make that positive 5, or the plus 5, disappear and turn into 0. So then y plus 0 is just y. But if we do it to one side, we have to do it to the other. All right, so minus 5 on both sides. And what it finishes with is y equals 3x minus 23, because we took that minus 18 and subtracted 5 from it to get our minus 23. The 3x can't combine with these, if you remember, because these don't have x's, so the 3x stays the same. Okay, so now we have our equation right here in slope-intercept form. So we can see that our slope is 3, positive 3, which is the same we could have seen up here, right? But on this one, it now tells us the y-intercept is at negative 23, okay, because it's our b value. So this might be easier for you. I don't know, it's up to you which one you like more. But again, now that we have it in y equals, we can graph this. We could put y equals 3x minus 23, or depending on your calculator, you could put f of x equals 3x minus 23. All right, hope that helped, guys.